All right, CNT140, Chapter 10, install. They have a reminder here about removing and recycling of old cabling. As we're doing the install, we might actually be encountering old cabling. And this might be part of the contract as well. We need to remove old cabling unless they have specifically labeled it as we need this later, we're going to use this later. It can be time consuming, but it has to be done because it is a fire hazard. And there is actually a National Electrical Code standard on abandoned cabling, and this is showing an example of like, hey, they do have a cable here labeled for future use. Maybe that's going to be for access points or something in the future. So we need to check to make sure this isn't. What is it connecting to? Verify it's not connecting to anything, and then carefully start cutting it out. And they remind us about recycling. There is actually recycling facilities that will take this, so that should be planned and part of the job. Outside plant install, much more diverse, kind of like a bunch of the stuff we were talking last chapter about planning for all this. Yeah, you might actually have a mixture of all of these, some or all of these in your outside plant fiber connection. So cables might end up being pulled into buildings, cables might be terminated at the top of poles, splices might be in various places that need to be planned for. So a lot more involved in your outside plant. You might need to have, contractor needs to know the route, then we need to walk the route, we need to plan it out. They need to inspect and plan for what might be coming, and might even be needing to plan for permits for certain parts of the job. Long cable runs in conduit might require intermediate pulls and figure eights like we looked at last chapter, even lubricant to make sure the pulling tension is not too high as they're installing the fiber. They remind us about the call before you dig. Absolutely. If you're installing in a certain area and call, there usually is a number like PA is 811. You call, they'll actually come out and mark where any utilities are, so you're sure to avoid them. And then obviously as you get your permits, you'll be documenting where yours is being installed too. Installs fall into 4 broad categories: underground, direct bury, aerial, submarine. We touched on all these last chapter. We're going to kind of refresh as we go through here too. Underground cables are pulled in conduits, usually buried a couple feet deep. Typically you're going to dig a trench to put the conduit in. With that, then you can be pulling cable through that conduit. With underground cables, you can do direct boring. It's possible. Here's a direct boring outfit. This could actually bore under roadways and save some trenching, digging up and trenching and so forth. As you're doing underground cables buried in conduits, typically you'll put a marker tape above that conduit so people know as they're digging that there is fiber optic cable below there. And this is usually a conductive tape. That way scanners on top, I'll say like a metal detector type thing on top of the ground could pick that up and know that there is a utility down there. Some jobs might require, especially if you're installing along, state or county roads or whatever, they might require as you install that you install extra conduits that can be used later. So you might use, 2 of these, but the other ones are here for future use. And that minimizes the amount of digging up of the roadway or through intersections that might need to happen in the future. When you're installing in conduits, only one cable can be installed in a conduit unless you're pulling a bundle together. If there's already a cable in a conduit, you don't want to pull another one through because it might do damage to the one that's already there. So if you do need multiple cables, it needs to be pulled all at one time through that conduit. As you're pulling, again, we might need lubricant for reducing the friction on the pull that's being done, and they remind us that make sure that is suitable for the type of cable that you're installing. You don't want the lubricant to cause the insulation on the cable to break down over time. They also remind us as we're pulling, we're using the strength fibers typically in the cable to tie the pull eye onto, and they remind us to use a swivel eye. This will twist and not the cable. You don't want extra twists in the cable as you go. And they do actually have, you're either going to monitor the tension when you're pulling, and that can be done usually on the equipment you're pulling with, or they actually do make a pull eye, this little swivel that has a breakaway mechanism. After so much force, it literally just pops off, so you don't end up doing damage to the cable. So, you know, that needs to be engineered and so you don't damage the cable. Some cables, the jacket is actually rated for pulling, but I would need a special, they call them a Kelman grip. I would need a special grip on here that actually grips the outside of the cable jacket. And you see it's almost like a, you know, as you pull on it, it gets tighter. This mesh here gets tighter on the cable. It kind of grabs the whole cable to pull it through. I might need a powered unit to pull through, but again, that needs to monitor the tension and set so that if it exceeds or gets to a certain tension level, that it stops. And you need to find out the cause of the excess tension. Where's the extra friction coming from? As I'm installing, I need to make sure I don't bend the cable too tightly. Remember the whole 20-time cable diameter under tension. When it's done, 10 times the cable diameter. And they're showing you here about, hey, this is the areas where you need to make sure you have protection, but making sure you're not exceeding the bend radius. Sometimes they're pulled, you can pull the whole length, but sometimes you might need an intermediate pull, where I pull so far here, lay the excess cable on the ground, do the figure 8 thing, and then continue the pull from here out to reduce the amount of friction. In some cases, if it's really long, you might actually start your pull here and go out this direction, and then start again here and go out this direction, and then splice at this point to reduce the overall length of the pull you're doing. Some of your conduits will allow the blown fiber, where you actually put a pressurized column of air through the conduit to reduce the friction on the fiber moving through. It does not blow the fiber through, it just reduces the friction on the fiber as it goes through. After pulling, we might need to plan for splicing the cables. And that's where your splice trailer or a splice tent comes in handy for a clean environment, temperature-controlled clean environment for terminating the fiber. You just need to make sure there's extra fiber to be able to get up to the trailer or into the tent for the termination purposes. Some fiber optic cables can be buried directly in the ground, not needing an actual conduit. It can actually be buried directly in the ground. In this case, I might be using a trenching tool. This is like this is a plow that goes through the ground, and as you go, the fiber is getting laid in there along with the tape on top. Actually, the fiber is usually out here on a spool. This is usually the marking tape here. Or we can do the direct boring, going under roadways and so forth. The type of cable we're dealing with is usually this type of cable then, the armored type. Water blocking, armor, and then the jacket out here is rated for direct burial. Here is an example of that cable plow. The plow itself here is making the trench, the fiber itself is kind of fed up through and down here and laid as it goes. And it needs to be, the people doing this need to be trained or well qualified and trained to do this, because there's a lot of monitoring that needs to be done with the fiber tension and the plow and so forth, as well as the ground that you're plowing through. And here is a style that's it's kind of doing the micro trenching action, if you will. It's doing the trench here, and the fiber is being laid in as it goes. Here is the micro trenching, the one where you're doing like almost like a saw curve in the ground, just a few inches deep, maybe a foot deep, and then your fibers can be stacked in on top of each other. Some installs might need to be aerial, up on your utility poles, telephone poles, utility poles, and now I need to make sure my fiber itself is capable of. One solution, as we mentioned last chapter, was to actually the messenger cable, the steel cable, is anchored to the poles, and then the fiber cable is lashed to that. And here actually is that lashing tool. It basically wraps the fiber and the messenger cable together, kind of lashes them together, wraps them together so they act as one unit. And here shows roughly the process you're using to do that. The other style of cable that can be used here is your aerial cable that actually has, it's all in one jacket here, if you will. The messenger cable is there, and then the fiber itself is underneath, and the jacket connects them together, and the jacket almost acts like a hammock to support the fiber here, with the messenger cable, the steel cable, taking all the tension. And here it shows you the idea of that aerial cable. There is some that are actually self-supporting. There is some fiber that is actually self-supporting, that the jacket and the structure of the cable itself can support that stress tension. But then you do need, it almost looks like a Kelman type grip again, that actually grips onto the cable over distance to support and anchor it to the pole. But you need those special types of attachments to do that. They also remind us of the optical power ground wire that utilities might use. This might be an aerial type of cable that gets used to connect point to point. Last one they mention is the submarine or underwater. Sometimes your fiber optic cable is going underwater. I'm just reminding you of the map we shared before of all the undersea cables that are out there. The cable itself is going to be more heavily engineered to resist moisture and protect against the pressure of a lot of water on top of it. And the install process is a lot more specific. You actually have to have a special boat that all the fibers laid into, and then you carefully lay it, kind of unspool it, if you will, on the way out. And then the process here's the fiber laying on the ground, and then you have a trenching tool like a plow that digs a trench and puts the fiber into. That is a whole specialized process. The going more locally under streams and lakes or rivers and lakes, maybe less so, but it's the same type of idea. You might actually be, the fiber itself might be going under a bridge, or it might actually be underwater. And either way, that usually is a specialized process to do. So our outside plant installations require special supporting structures before the cable install. And that is a lot of these types of pedestals or splice areas that are needed to be in place before I can do this. I might need new conduit or interduct, but I might also be able to rent existing conduit or interduct that's there. I should say conduit. Splicing cables, again, we need to make sure as we're pulling two cables, I need a spot where I can splice them, and I need cable to be able to do that. I either need the splicing trailer, splicing tent, or some cases I may need a bucket truck that has protection that I'm doing the splicing up on the pole. But I need to make sure I have places for, as well as protection for when I'm splicing, and a plan for where is that going to get done. And then the end, I need to make sure I have some sort of splice protection. Here is a pedestal that would get used outside. The splice is in here, cover over top. This might be the kind of thing that's either in the ground or up on a pole. Could be up on a pole too. Here's a splice case with protection over top. Here would be a splice case that gets put into a underground vault. And then the lid put on top, the waterproof lid, a gasket and seal around it to keep the moisture out. With splicing, once your splice is done, it needs to be verified. It needs to be tested. And typically, after you do a splice, they're going to do usually an OTDR test on it kind of right then and there, because all the equipment's there, your technician's there. If it doesn't test out okay or shows too much of a loss, you could re-terminate right then and there and not have to dig it all out of the ground, if you will, or unbolt it and get it out of the ground to fix that splice. There is such a thing as a mid-span entry. Sometimes you don't have all the fibers go the whole length. Some of those fibers might get pulled out part way and routed to a different location. So there is actually utilities and tools to do that, to pull a fiber or a couple fibers out of the middle of a run and route them to maybe that building. So think about a fiber going across campus, a large fiber count going across the whole way across campus, but as it goes by buildings, 4 fibers get pulled off and go into that building. 4 fibers get pulled off and go into that building. Maybe that kind of scenario. So there is equipment and procedures to do that. We mentioned before about outside plant fibers don't typically meet flammability ratings. So as the cable goes from outside into inside of the building, it has to be planned for. They do have, some cable are double jacketed, where the outside jacket is okay for burying. Once it comes to the building, you cut that jacket off and that armor off, and then the inner jacket here, it's kind of right under there. That would be the one rated for inside. And then that cable can be routed to the termination point, distribution rack, etc. in the building. I might need some breakout equipment to do some protection around those bundles of fiber. So I might need some additional equipment as I'm doing that to protect those fibers. We'll come back in the next podcast and keep on rolling.